force is going to be. Like, I don't expect you to get this answer right. Like I do expect you to get this answer right, but if you do not get it right, it's okay, because we're going to be going over it today in class. Here you go. Without looking in the back of the book. Good try. I was like, wow, how did you know that? No, looking in the back. It's an encyclopedia though. Okay, I'll give you another minute. Tyler, no.
I glance.
You glance. Okay.
That's the same thing.
So yesterday, what did we talk about? A lot of friction. What else? Magnetic force.
At least I was smart enough to look in the back of the book.
Okay. Well, what did you learn yesterday? Jeremy?
Gravity.
Gravity.
Gravity does and how fast things fall.
How fast do you think it's going?
10.8 meters per second per second.
Thank you, Jeremy.
Jeremy? How we all said that.
Sounds fair enough. Okay, so today we're going to be learning about balanced and unbalanced forces. And to do that, Mr. Zay and I are going to be demonstrating a little bit with this tug-of-war rope that everybody's been asking me about.
Tug of what?
Tug-of-war rope.
Where is that?
Tug-of-war. It's a very large rope.
Where is it? Are we going to use it?
Quiet.
See it.
It's meant to be a little bit hidden. But when a force is balanced, what do you think, guys? Think that's gonna? What do you think is gonna happen? Not yet? You know? What? Forgot. Anybody else think they know? Jade. Just give a guess.
When a force is balanced, maybe it's like the same strength. They have the same strength.
Jared, please sit down. Tommy, please sit down. Yeah, that's a great guess. So what we're going to demonstrate right here is we're both going to pull at the exact same force. So what's happening right now? Jeremy?
Nothing.
Nothing. Exactly. A force is balanced when both sides, sit like this, a pull and pull, are exactly equal. So what happens if Mr. Zay pulls at more force than I do? I go forward. What do you think that's called? If it's not balanced, it's unbalanced. That's right. So why do you think that is? What's happening that's causing him to pull me forward? Jeremy?
You're not using as much strength when pulling the rope.
Yeah, exactly. So now, and on your table, no, second. Mrs. Gunaldrum, this is Mr. Bride. Hi. Okay. Okay, sounds good. Okay. Zay? So there's a paper, there should be a paper on each table. That's just if you get a little bit behind and need to write it down a little bit better. You need to write it down. If we move on. If you don't have it, it is okay.
Why are we doing Netflix work?
Spencer? All right now. So, Spencer. Like Mr. Zay and I just demonstrated, and Jaden said, a balanced force is when both forces are equal. They're not going to be moving. They're not going to be moving because both forces are the exact same. Because of force. Yeah. So balanced forces act on an object, but it balance each other out. So, what I originally wanted you guys to do was we would all be going playing tug of war, but obviously the weather's not really permitting us to do. So you can't really feel that, but I think you guys all get a good idea, right? Am I right? Okay. So a key thing about balanced forces, the forces are always going to be balanced as long as they're not moving. Does anybody have any questions so far about that? So when Mr. Zay and I were pulling that tug of war rope, if he started to use more force than me, what do you think would start to happen? Jeremy?
You would go forward and you would go left.
Yes. So in tug of war, what usually happens if he pulls me past a certain point and say there's a mud pile, what would happen?
Go in the mud.
I go in the mud. That's right. But obviously I'm not covered in mud. Oh, thank you. Okay, so does anybody still need to write this down? Alright.
I do.
Sounds good. So are there any other questions about balanced forces so far? So as Mr. Zay and I already demonstrated, forces are unbalanced when what? Yes. More force than the other. It's all about forces. Yes.
More that has more momentum.
More momentum?
Yeah.
Yep, that's also right. So when unbalanced forces act on an object, motion changes. So, like Mr. Zay and I demonstrated, when we were pulling it the exact same, I and he was not moving. He and I were not moving. But when he started to pull with more force than me, I started to move. Yes?
Me?
Yes.
Why did you pull it?
Demonstration.
Can you try it?
Maybe. Probably not. So what happens, so unbalanced forces also can happen when somebody's ice skating and they go right into a board. What's going to happen at that point? Go on.
What happens when you get the board, sometimes you, like, you're going back a little bit, but it's stop when you run into the board.
Yeah, exactly. Eliana?
You could also like put the board over, but you would stop because you can't ice skate on the board.
Well, in this circumstance, the board would not move at all. Let's just say the board's a lot stronger than you are. What? How much you weigh, how much force you have, how fast you're going. There's a number of factors that go into it.
Yeah.
Does that make sense?
Yeah.
What was your butt? Like you said, butt. So the object may start, change direction, speed up, or stop. So is there any questions about unbalanced forces right now? Does this make sense to everybody? Yep.
Right.
Fairly easy. So, while everybody's still writing, think about a seesaw or a teeter-totter. Does everybody know what that is? Does anybody not know what that is? Spencer, what's your question?
What is an unbalanced force?
An unbalanced force, did you see when we were demonstrating?
Not really.
Not really? Okay, let's demonstrate it one more time. So, Mr. Zay and me are pulling in the exact same, but when he puts more force into it, brings me off balance. That is an unbalanced force. So a balanced force is when the forces are pulling each other or pushing each other exact same.
Can you say more force?
Maybe. So think of it, when we had our hands together the first day with using the clickers. So an unbalanced force is, say you put more pressure on your right arm than your left arm, so you push over. Does that make sense? Spencer?
No, I went like this.
Does that make sense though? So now we're going to be thinking about a teeter-totter. Teeter-totter or a seesaw? Seesaw. Different people have called it different things. So, say that I have a twin and we're the exact same weight. What happens if both of us are standing at the same, or sitting on it?
It's gonna stay in one spot.
Stay in one spot. Why?
Because you both weigh the same. And
What is that called?
it's a balanced force.
It's a balanced force, that's right. So, a seesaw or teeter-totter shows unbalanced forces and balanced forces. When do you think it's balanced? Alana.
Like, when it's balanced, it's like straight out.
Straight
like
out.
in the middle.
Why? Why? Just because it's just standing still?
Yeah.
Like that? When is it unbalanced? Jeremy?
When the object is like this.
So, is it unbalanced when it's just like barely tipped? Or is it still balanced?
It's still unbalanced because the side is going.
What? Speak up.
It's still unbalanced because it's not so.
That's right. So, a seesaw shows balanced and unbalanced forces. And if the weight on one end of the seesaw is heavier than the other side, the heavier side goes down. So how does a seesaw work though when you see a dad and a kid going on one side? So why isn't the dad always going to be on the ground? Kyler.
I don't know. Kind of like you push down.
What does that create? Okay, it creates an unbalanced force, but, so I think you went a little bit too far. I was saying it creates a force that goes up, right?
Yeah.
Makes sense. So, you were right. So, but what happens when the kid touches the ground? Is he really going to touch the ground, or does he even need to push back down on the ground? Why? The dad weighs more, and the force that doesn't really need to happen, right? So what if the dad just jumps off? What's going to happen then?
The kid's gonna go down.
The kid's going to go down. So who has